characteristic shape. But the one thing we want to do is want to look at the detector itself. And that's what I got wrong last time. Okay. And all right, I know what I want to show you guys. So one thing is when we look at the EKG, the y-axis is in millivolts. And just give me a minute. Yeah. So the EKG readout is in millivolts, a very tiny signal. And so I wanted to show you what we have to face when we take a measurement that's really very tiny, millivolts, 1/1000th of a volt. And so I've got this digital oscilloscope set up. And it's basically, I just have this probe connected to it. And you notice that there's lots of stuff there. And actually, the biggest source of noise there is actually the 60 hertz noise. Let's see if I can. No, I can't. I can't do it on this scope. Well, take my word for it that the predominant noise is the 60 hertz, and we're stuck with that because I can just stop it. So the biggest one here, that's a quasi sine wave, is since our electric generation is done at 60 times, we have AC, and it's a sine wave at 60 hertz. So what I can do is I can demonstrate that better here I've connected now this probe thing to this wire outside my house because I was making a radio in my electronics class. So that 60 hertz noise, there's nothing we can do about. And I tried studying the EKG sensor and to determine how it takes care of the 60 hertz noise. And I'm not really sure. What I think is it does that because by having the 3 terminals. Excuse me, I just have to get this thing back up to where it was. There we go. So let's put that over there. Oh, touch something. So notice, though, that there's lots of other stuff going on. So number one, the EKG detector has a way of getting rid of the 60 hertz noise, and I'll give you my thoughts on how it does that. But now, if I change the number of volts per box, here is the trigger icon. Hold on here a minute. Okay. Notice that there's wiggles within wiggles. So there's higher frequency stuff. We're at 5 millivolts per box. Now, right now, they're not super big, but they're still on the order of millivolts. And then look at this now. There's more wiggles within wiggles. And then even more wiggles within those wiggles. So we might be seeing, can we see cell phone signals now? No, because this is microseconds per box. So the cell phone signals are even in there, or the Wi-Fi. I don't know. Oh, yeah, I can. Holy crap. It's just hard to keep. The other things are wiggling. Oh, that's my best sensitivity. So I don't know if I can. Maybe 20 nanoseconds per box. That might be cell phone. I'm not sure. This oscilloscope is nice, but it's not super expensive. So there's all these different frequencies in there. So keep that in mind. There's noise all around us. Now what I think happens is that the way they get rid of the 60 hertz noise is that we have three of these clips, and one of them is positive, one of them is negative, and one of them is ground. And so the black one, what it does is that instead of being an earth ground, meaning it's zero, excuse me, it goes up and down at 60 hertz. So then the difference between the green and red and the black are what we measure. And that's how we get rid of the 60 hertz. But, don't worry too much about that. So the first thing I wanted to show you So what I did is I had this bright idea this morning. See, I put all three of them right next to each other. And then I clipped these on. And now they're all tangled, of course. Okay. And so let's look at some data. So I've got this thing set up so it won't start because it's giving me a chance to hold my arm steady, because what'll happen, see, I'm talking, it can sense it, the low frequency. If I move my hand, see that? So it stops at 10 seconds. And that is 50 hertz. So let's try 200 hertz. In fact, I notice, and that's me talking, me moving, it's totally consistent. It's only, I thought it was tens of millivolts. It's only ones of millivolts. Now this is really trippy. So now, at 1 kilohertz sample rate, we get to see, we're seeing more and more of the high frequency noise. So that's why it's thicker, because the amount of power coming into it. And you go, all right, so I better stick with the low frequency sampling rate. But one thing I want to show you is this thing called the smoothing. And notice, and this is basically when we average the 14-day average with the COVID. If I average the points together, notice that no longer do we see that much variation. So when we average them together, what we're doing is we're getting rid of the higher frequency stuff. So I can do it with this guy. So now instead of averaging 7 points, I ought to, and so on. So just write down in your notebooks that this is called, this here is like a complicated algorithm we're not going to get into. But this is, we just call it a moving average. And I'm going to explain what a moving average is before we go home. So there's the background noise, right? So you say, oh, well, maybe we're going to do another background subtraction. Well, it turns out it's not that easy to do. So I'm just now, you can't see it, but I'm going to put these things in the places where they're supposed to be. Okay. Oh yeah, let's get the picture so I know where to clip in. Lab manual. There it is. So, right. Oops. So I did goof. I'm supposed to get two of them on the right side. All right. Nope. So red on the left. I always somehow think I'm looking in a mirror. So I clipped them on. Well, we did it in my other classes did too. We always get this wrong. I can't believe it took me like 3 or 4 semesters to figure this out. PhD and blonde hair. Okay. And then our son Christian gave Jenny for a Christmas present a joke book. Blonde walks into a bar, and I thought it was kind of clever, but it almost backfired. She was a little pissed off. Don't tell anybody I told you that. Okay. So let's see. We want to. We don't want to see these anymore. And so how can we? Yep. Okay, so let's do, first we'll do 50 hertz. So remember now, we're looking for the characteristic shape. And my data quality is that I told it to wait for 5 seconds, and then I told it to take data for 10 seconds and stop. So this way I can click on my mouse to start it, and I can then settle down, and then it shuts itself off, so I don't have to click on the mouse to stop it and then mess up the data. So notice that we can sort of see the characteristic shapes, but is it there? Is it not there? And we say, well, of course, we don't have enough data points. Remember the sampling rate. So let's try 100. So notice that even with 100, we might not feel super confident. I mean, they're beginning to get there. Okay, so let's go up to 250. And let's get rid of this one. So we say, well, wait a minute. I thought it would get better. And in fact, it sort of got better, but notice that the crazy wiggles, there's more crazy wiggles. And of course, the reason is that we're allowing more of the the higher and higher frequency noise come in. And so let's try 500. And it's like, oh my God. So what's happening here is that we have a fight between sample rate and noise, letting more and more noise come in. Because at 500 hertz, and let's just square the circle. Here's a kilohertz. And in fact, I'm surprised that it doesn't show a higher amplitude, like more noise being let in. So that's just stunning, right? It's like, how the hell could we get anything out of that? Well, if we do smoothing, averaging, look at that. Isn't that amazing? Now one thing, now it's not so good to look at this one. Let's look at only the 500 hertz. Okay, so the thing to notice, all right, so make sure you're writing stuff down. So we can really bring it out. But you notice there's less and less points. But basically, now we can really see all the landmarks that we need to see. Now, there is a limit to this. So let's see. This is the 100 hertz. The problem is that if we don't have enough data points, then you notice that the peaks we start to lose the shape. So in fact, the number of data points don't change, but if you think about it for a minute, if we're going to average nearest neighbor points, we want to have them very close together, because now what's happening is if I'm averaging together 50 points, then I'm averaging in points that aren't included in the part that I care about. If I look at the higher frequency stuff, see, if I average together 50 points, then they're all going to be, let's highlight that, yep, let's unsmooth it. Let's see if we can zoom in together. Right, there's so many, you can't even see all the points that are in this peak. So if I average together so many of them, they still represent what's in that curve. So we need to have a high sample rate so we can match the EKG, the real EKG curve. But because our measurement is so tiny that the higher the sampling rate, the more data points we take, the more of the noise gets in. All those wiggles within wiggles are being admitted. All right, so let's take a look at our spreadsheets. And I'm going to zoom in a bit for you. Okay, so we, in fact, I have to remember, oh yeah, okay, first of all, let's just select this, and we'll make this bigger. Then we can just go up here, and we can center it horizontally and vertically, and then we wrap the text, see what that does. And then we can clean up the way the numbers look. And I think 3 decimal places should be good enough. And I also think it's a good idea to insert spaces between each one. All right, so now we need to, this, you see that it's 0.002 seconds, so that's, if you do 1 over that, this is the 500 hertz, and this is the 1000. I think this is, this one's 50, because 1 over 0.02 is 50. And this one, that's 0.01, so that should be, it's 100. Because 1 over 1, it's 1/100th, right? So that's just 1 over 100, so it's 100 hertz. What's the time? We'll get it done. And this one I don't remember. 4. So this is 250 because this is 4 1,000ths. So if I do 4 into 1,000, that's 250. Okay. So here's your analysis tasks. Want to plot. Let's see how I can do this. Oh no. This is let's try 200%. Okay, so we want to plot the 50, the 100, and the 250. 50, 100, 250 on top, all on one plot, And let's see, what happens if we do the 500? All on one. Okay. Trouble is, this is, it's hard. This is one thing, advantage that Google Sheets has. Oh no, but Google Sheets only allows one column for time. So we want to do insert, charts, and we want a kind with no points. Do we want points? Yeah, let's do with straight lines with points. Okay. Then I want to clean it up. Where is it? Series. There we go. We want to make the marker really small. And then I want to make the line a different color. Doesn't matter what color it is. And make it small. There we go. In fact, you probably could like only take a portion of this. Now how? Now we want to add data. This was where it gets a little tedious. Select data. So we add, and the series name is going to be the 100 Hertz run. We click on that box. And the X values. Oh, right. This is one where we can get a little clever. I forgot to do that, but we'll just go and we'll, since this won't be ridiculously long. Starts at 10 seconds. So 1002. Now, watch this. The Y values. I'll show you how to get a little clever. We'll start here, the Y values, but then we'll just go here and type the 1002 here. I don't know how to zoom this. And there it is. And I'll show you how we'd be clever ahead of time. We need to add the 250 to it, right? So we want to go down and find out where 250 ends. And it ends at 2502. Okay. All right, so now I want to add select data, add. So this is the name of the series. The x-axis, we just take a few of them and then we type into here 2502, and then same thing here, and then 2502, and then I already showed you how to format, so I'm not going to right, and then we add the 500. So for the first part, you say, okay, we're supposed to be making this characteristic shape. So that's sample rate. So first of all, just like blood pressure, we're going to decide on sample rate. Just like we did, we're going to put on top of each other 50, 100, 250, and 500. And I suppose I should give you some illustrations for noise. And so now you have the characteristic shape. You know, we remember that there's the sample rate, why we care. And we have our characteristic rate here, a characteristic shape. Quite. Of course. Well, I'm going to go back. I'm going to go. Yeah, this one here, I'm going to go to it. It's next. I'm just, see, sampling rate, I'm making a slide just for it. So we're going to plot the data. And you say, well, look here, I went to 50, 100, 250, 500, and compare it to the characteristic shape. And you might say, well, 250 could work. But you're saying, look, 50 is not good enough, 100 looks better, 250 looks better, but it's something about it's bothering me. And then when I go to 500, it's like, oh my God, it's horrible. And we say, well, 250 could work. And then you say, look, we realized we're getting more and more noise. You know, just yell at me to go back. So we really want to be able to, and then we talk about that it's in millivolts and there's lots and lots of noise all around us. And I'll give you some pictures for that. So we want to try to figure out how we can do something about it. And we're going to do an averaging technique. I'll go back. I just want to see ahead what I have here. All right, so I haven't gotten that far yet. All right, so get that going on. All right, again, just yell at me if you need it back. So what you're going to do then, you're going to make another graph. And remember, this needs to be prettied up with labels and things. We're going to take the 500 hertz and make a scatter plot with just straight lines. Now, do we want just straight lines? No, I guess. Yeah, I've done it with straight lines before, but I want to, let's stick with the points. This is a mess, of course. But we're going to do just before, we're going to make the markers very small. Fact. I also remembered a way to make them even smaller. If I set the, we'll eliminate the outline of the point. We'll just stick with the fill. Yeah, notice that they get really small. So this is before, and we want it to be the same color just to make it dramatic. And then we say no outline, and they get smaller. Okay. Just write notes to yourself right now, because this video will be posted. And then I want to make the line a different color, and I want to make it really, really thin. And yeah, let's think about this. Okay. All right, I can think of some variations on this. So I'm changing what I told the people on Monday a little bit. Okay, now we have the chart selected. We're going to insert a trend line. And we want moving average. And it's already helping us, see? And let's format the trend line. And I'm going to make it red. And I'm going to make it a solid line. Oops, no. Where is it? Here it is. Yep. I can imagine that I want to change something here. The series, I can already see that I want the line to be some dull color. There we go. And now what we can do is we can look at the trend line options just like we did before. That's amazing, only 2. Notice that even odd numbers don't do so well, because if you think about it, if you have these overlapping sine waves, you want to have an even number so that they can get canceled out from each other, cancel each other out. And now we're just sort of getting an idea of what works best. I could see 10. I could see 8. Nice, huh? And just as I want you guys to know what a moving average actually is, insert, and we're going to create one. So we decided on 8, I think. Yeah, 8. Okay. So here's what we do. Oh, can't get that off the screen. So we want to go 1, 2, 3, 4, 5, 6, 7, 8. So first of all, we want to have averaged 500 hertz, something like that, just for until we know what it is. And I can't think of a average. Oh, wait a minute. So this is, yeah, we need 2 of them. We need let's insert another one, because we need X and Y. Time, average T in seconds. So we're going to have to just make this wider, just like above. And yep. And averaged voltage. in millivolts, 4 to 500 hertz. Okay. So here's what we do. So equals, why isn't that working? Oh, maybe because I'm resting my hands on my tablet. That didn't hurt before. All right, equals, what's wrong? Well, it's busy doing something somewhere. What time is it? Oh, we're almost there. Somehow when I do this, I use Task Manager. It kind of kicks it in the butt a little bit. There we go. So this no. All right, maybe there's some dialog box in the background I'm not seeing. All right, let's try saving it. Maybe that'll help. All right. Oh, it's not flashing anymore. But it's still not letting me do it. Why not? Is my keyboard all right? What happened here? Oh, I clicked in the bottom. I double clicked. There we go. So we want to average this one. 1, 2, 3, 4, 5, 6, 7, 8. Close it. And something went wrong. Oh, it didn't remember. Average. And then close the print. Well, it's getting funky on me, guys. What if I don't know, hopefully it's not happening to you. All right. And let's get rid of this. Ha! Why is that here? And that finally worked. Same thing here. Equals average. So we're just averaging this one, 8, and back into the past. So 8 values. Now, watch what happens if I drag it down. It went J2 to J9. But now it should be J3 to J10, etc., etc. So that's what a moving average is. There's a function called moving average, but I wanted you guys to see what it looked like. So then we just plug it in. And now this is a pain in the ass. I don't know how to get around this. This should be about 5,000 lines. There it is. 5,002. No, that's not a big surprise. And it doesn't go to 10 seconds anymore, of course, but that's fine. We got to remember 5,002. Okay, so now just to make our lives easier, we're just going to create a new graph. And let's try that. This is something I don't know if I've ever done before. Now we want a... whoa. What is that all about? Oh, I know why, because it's only a few data points. All right. Select data. That was like weirding me out. What the hell? Edit. So the name of it is this. And then the x-axis is then to 5002. And of course the y-axis is also to 5002. And there it is. Isn't that nice? And so now we have smoothed it. Pretty nifty, huh? And because we're running out of time, I will put up mine that I used. It may be in another video. Microsoft Excel. Oh, right. I need to get into the right blood pressure. There it is. Cardiovascular. It should be, huh? Let's see. Study the 5th. Hopefully I've got that there. If not, no. Okay. We need to do, there's questions in the logbook, in the manual, excuse me, about is this a normal amount of time of this and that. But I summarized that because I don't want you to fill in those tables in there. Let's go to here. So this is from Monday, but it's slightly different, right? So I said to put, no, there we go. Put all those four. Scatter plot with straight lines with the with tiny dots. The reason is you want to show that there's more with the higher sampling rate. So this allows us to do the average. And we said that the 250 was okay, might be okay, but we want to use the 500 because we want the information. So we decided to do the average. We decided to do smoothing. So we need to explain what's going on, what a smoothing is and what it does. And that is, it basically gets rid of the high frequency stuff. The moving average eliminates the high frequency noise. And we need lots of data points because we want to make sure that our moving average, yeah, let me draw a picture of that. Now I know what to say. If we have some thing we want to see this, and we want to do a moving average, and let's say it's 8 points. We want our 8-point window to be a small part of the graph. So for that to be true, we need a shitload of points. So that 8 points only covers a small range. Because if we have only a small amount of points, then if I take 8-point average, then I'm now have too much. I'm losing all this. So we need a high sampling rate to do an average. And then the trouble is the high sampling rate. Trouble is it lets in noise. So the high sampling rate lets in the noise, but if we do an average, we can get rid of the noise, and in fact, then the higher sampling rate is our friend. Oh, we got 2 or 3 more minutes. It's good for averaging. So this is how we defeat the problem of high sampling rate, because we need the high sampling rate because we want to see the curve. But we let in the noise, so we do the averaging to get rid of it. And we're conveniently closing our eyes to the 60 hertz noise, which should kill us because heartbeats are about 60 to 70 hertz. But again, I think it has something to do with this instrument, but you guys don't have to worry about it. We're just not going to talk about that. Excuse me. And so we need to add vertical lines to be able to measure these various things. And I posted a video about it, but I want to find this spreadsheet that I made with those vertical lines. That's a CSV. Here, maybe this is it. Yes. And I built in this neat feature that I can move them around to take the measurements they want. And then I can just change the offset. And where did I put it? Here. So then I could change the offset to just simply move all of them over to the next set. And this is definitely in the YouTube playlist. And that way it's asked questions in the manual. And remember, you do not have to fill in these tables. But it says it asks some questions here. So you can definitely answer these questions. And then we'll talk about how to tie it all up into a report next time. Let's see if there's anything else. No. Same thing here. Not here. No, I already talked to you about how to do the analysis for the blood pressure. Wow, we made it. Any questions? Yeah, you're probably all pretty glazed over. So, but remember, you can ask me questions asynchronously. Oh, where's here it is. I want to stop this recording. I'm also already asked you guys to do a lot of work on this one. So let's just see what we're supposed to measure exactly. Using table 2, the beginning of the P wave. In fact, what we need is let's do a snapshot of that. Yep. So we have that to refer to. And where are you? Here we go. And we need a snapshot of the actual waveform, so I can see where I've got to improve this even. All right. No, not there. And paste. So hopefully that goes on the front. Yep. And so it says the beginning of the P wave. Oh, so that's the PR interval. We need the PR interval. So remember I was saying in class, how many vertical lines do we need? So it looks like we need the PR interval. So we need 1, 2, because then it says being the beginning of the Q. Showing let's do this. Or do you get the time? Okay. Measure the time from the beginning to the beginning of the T wave. And the T wave is here, the beginning of the T wave. And okay. So that's, well, we only need 3. Well, you know, I'd like to know what the QRS is, so I want 4 vertical lines. Okay. Now, let's make some room here just so we can see what we're doing. All right. T1. So let's see. Turn off the tablet. So actually this is beginning of the P wave. And didn't that look good, huh? I'm gonna pause for a minute. Alright, I'm back. You didn't notice any difference. So beginning of the P wave, beginning of QRS, end of QRS, beginning of T. And then I have a column for y-axis points, and then I have the P to QRS, the QRS interval itself, and the QRS to T as stated here. So I suppose this is the also this is what the ST, and then this is the PR. Okay, so we know exactly what we're talking about. So I'm going to end it up on this graph here. One thing I do, I'm going to copy and I'm going to paste. So now I've got this one, and I am going to get rid of the, I just want to keep the trend line. So I'm going to get rid of the, there we go. And then we could change this here. And let's call this 1.5. Nice, huh? Cool. Okay, so so we see this goes from -1 to 1.5. So that's our y-axis minus 0.1, excuse me. and 1.5. And I noticed that this first one is at about 3 seconds. So I'm going to put a 3 there. And, oh yeah, I can get an estimate. In fact, I have another idea. Right. So, wait a sec. I am going to take this and I am going to copy, and then I'm going to insert. Yeah, okay, good. You'll see why I did that in a moment. Okay, so these are the these are numbers I'm going to put in or calculate. There we go. So let's see, about 3. This is about, oh, it doesn't say that, yeah, because it's a trend line. Okay, so we'll just call that 3.2. We can fix this, you'll see. 3.2. The end, let's say it's at 3.4. We just have to estimate. And then this is, say, 3.5. And then I'm going to, give me a minute. Right, so then I'm going to insert, I'm going to add something else here called, I'm going to call this offset, and you'll see why in a minute. And it's first going to be 0. Okay, so begin of the P wave is going to equal this plus the offset, and then equals this plus the offset again. If I were, well, here, watch, I'll show you how to do it better. Y2, we do the dollar signs with the F4. And then we can just drag it across. And then if I add the offset, they all change. So that's going to change the position of the vertical lines that we're going to put in there. And you'll see why we're going to do that in a moment. So P to QRS is going to equal this minus the P, and oh, excuse me, that's not what I want, because I need it to be, I need the offsets in there. So that's going to be equal to yep, the P2 here minus O2, yep, and then this, can I just drag that across? Yes, because let's see, this is, yep, that gets us to QRS, and that gets us the QRS to T. Nice. Okay. So then, this now, it's kind of dumb, but we just say equals to what's just above it. And we drag that across. Sweet. Now we add select data. And it's a little tedious because it's going to be 4 different lines. Add. So begin. And then the X values are here. And the Y values are here. And where is it? I don't see it. Why is it not on this graph? Well, let's say okay. And pause time. So I just realized a mistake I made. We don't want to use, remember I copied and pasted the 500 hertz, but I actually don't want to use that. I want to use this new one I wrote, and this is, let's make it more formal, voltage, millivolts, 500 hertz, 10 AVG. There we go. And we want a different title than that, but that's the name of the data series. And so what do we say? 2 to 8, there it is. We want to add this, and I know why it didn't show up a minute ago. Select data. So add once again. Oh yeah, once I do this, I can scroll up. Begin P wave. And then the X values are here. And the Y values are here. So yeah, there it is. Nice, huh? Okay, so I'm going to pause now. I'm going to add the other ones in. So I just realized that I should show this because little subtlety. You probably got it, but let's just make sure. Now I'll add the fourth one. And that is the beginning of the T complex. And then the X values are here. And so each time I'm choosing a different X values, but the Y values are the same. And even though it's only 2 points, I get lines because this I have told it to be aligned. So this here is not a good color. We don't want blue. What have we not used yet? Sort of dark greenish, huh? Okay, so now we can tweak this a little bit. And so it looks like 2.8. Ooh, no way. 2.95. There we go. 2.96. And it's getting there, huh? 2.97. Nice, I got that one. So I'm going to pause. So now I've made it to messing with the beginning of the T. So let's see, it was 3.4. Let's make it 3.3. Oh, no, maybe it was 3.5. Let's see, 3.4. Ah, there it is. 3.45. And so on. So you see how you mess with that. And now you get the intervals they want. And I made it easy. Now what you can do is you can just offset it. Meaning like I want to move to the next. I type in the 1. And I see where, okay, let's try 0.8. And it needs to be a little bit better. In fact, I even have something clever to do to make it, to do the offset even better. 0.9. And so forth. So now you can go and just double check each time to see if the intervals are basically the same. And pretty nifty, huh? But there it is. So that's how you can measure the numbers they want. So for us, we just want to double it. The important thing is that we understand what the averaging is. And excuse me, and just to do a couple measurements of the of these numbers they want. So this, of course, can be jazzed up. We don't really need all those significant figures, for example. So we can get rid of, it says link to source, so we don't want to do that. So, oh, sorry, this, we can do it here. So 0. So, well, maybe I like to have 1 decimal place. It looks a little nicer. There you go. And same thing here. Oh gosh, maybe just 1 decimal place. And then you can add labels. You go up here. And there you go. Neato Kino. I just realized I forgot something. Well, I mean, you should know it by now, but it's always a great, among other things, a title for the graph, titles for the axes, what the legend. It really it helps when you're actually making the graph. But and then you can, I always put it in at the top. Then you can format it. I just noticed that I liked having them all stack up like this. I can make a background fill so that it hides the grid lines behind it. And you can change the size of the font. And yeah, nice, huh? There's even a way to add to the legend these numbers here, but let's not go too crazy. Great. So at the end of the day, you're going to have the 4 basic plots. You're going to show this with the trend line with the moving average of 10. And then you're going to create a moving average, make a plot of that, make the vertical bars, and measure these intervals for a couple of these, just to to demonstrate that you can do it. And you can make a comment as to whether or not it's normal, but I'm not asking you to do the table 2 and 3 in the manual. So that's out. Very good.